So today we are going to discuss some MCQs, important MCQs in solid state chapter. So in that first question, if germanium crystallizes in the same ways as diamond, then which of the following statement is correct? They are expecting which of the following statement is correct. So first one, they have given germanium crystal as well as and diamond. So they are asking with respect to diamond, so that we should know about diamond structure. So diamond is similar to FCC structure. Diamond is similar to face center cubic structure. Along with face center cubic atoms, their 4 atoms are extra. In case of diamond, along with face center, 4 more atoms are extra. That 4 more atoms are occupied alternate tetrahedral voids. That 4 atoms are occupying alternate tetrahedral void in case of diamond. Okay, so in this, which option is right, which option is not right, we have to check. First option, every atom in the structure is tetrahedrally bonded to 4 atoms. Yes, in case of this one, every atom will be bonded tetrahedrally. We know that diamond is having what? Covalent bond. Diamond is strong due to covalent bonds only, network bonds. Strong covalent bonds, as well as these bonds are continuously connecting one carbon atom with another carbon atom. So that we call it as what? Network bond. So because of this network bond, this diamond will become very strong. So we know that carbon valency is 4. So that in case of diamond, so 4 carbon, one carbon atom will connect with 4 more carbon atoms. So valency of carbon is 4. So option A is right only. So next, unit cell consists 8 germanium atoms and coordination number is 4. 8 germanium atoms they are telling. How that 8 germanium atoms we are going to discuss. So now here you see germanium atom crystallizes in the same way as diamond. So germanium atom crystallizes same way as diamond. So means now the germanium crystal structure is equal to what? Diamond crystal. Diamond crystal structure will, both the structures will be equal. Just now we have seen diamond is what? FCC structure, and along with this FCC, 4 atoms are extra. These 4 atoms are occupying at alternate tetrahedral voids. Alternate tetrahedral voids. Okay. So in FCC structure, total 8 tetrahedral voids will present. Total 8 tetrahedral voids will present. So they are telling 4 alternate voids. Means tetrahedral voids is not tetrahedral voids completely tetrahedral voids contribution is completely to that unit cell only. So it is not shared by any other unit cell. So that's why tetrahedral void atom, total tetrahedral voids are 8 and 4 tetrahedral voids it is occupying. So that the atoms which are occupied at tetrahedral void will be 4. And number of atoms in FCC. So total how many atoms are there in FCC? 8 atoms are there. Their contribution, 8 carbon atoms will present. Their contribution is 1 by 8. Plus 6 face center atoms are there. Their contribution is 1 by 2. So then 4 plus 4 are tetrahedral voids. These 4 atoms present on alternate tetrahedral voids. So 88 get cancelled. Then this is 1 and 2 1 ja, 2 3 ja. So this is 3. Total how many atoms are there? 8. So 8 germanium atoms. Unit cell consists 8 germanium atoms and coordination number is 4. Its coordination number is 4. So this is also right. All the octahedral voids are occupied. Here only tetrahedral voids will occupy in case of diamond, but octahedral voids will not occupy. So which one is not correct they are asking. So this one is not correct. Option C is not correct with respect to this question. So next option also you see, all octahedral voids and 50% tetrahedral voids remain unoccupied. Yes, octahedral void is not occupied and 50% tetrahedral voids also unoccupied. Yes, it is right. Why? Because total 8 tetrahedral voids are there. In this, alternate tetrahedral voids are occupied. How many alternate means how many? In this 8 alternate means 4 only it will occupy. So 4 is 50% of 8. So that this option also right. In question they are asking which option is not correct they are asking. So option C is not correct. Why? Because all the octahedral voids are occupied they have given. but all octahedral voids are not occupied. I hope this first question is clear. So next we will go for second question. So in this second question, if we mix a pentavalent impurity in a crystal lattice of the germanium, what type of semiconductor formation will occur? So it is very clear. Semiconductors means which substances conductivity will increase by heating. Such type of substances are called what? Semiconductors. The semiconductor's conductivity is in between conductors and non-conductors. So here germanium is a semiconductor. We know that germanium belongs to fourth group element. So means carbon family, 14th group or fourth group. Germanium is having what? Valence electron 4. Just you observe carefully, germanium lattice structure will be like this. One germanium and second germanium will join with third germanium. So these all are germanium units, germanium unit cells in crystal lattice of germanium. This is also germanium, this is also germanium, and this is germanium. So these all are having same size. Here I given large, but every germanium size is same. Germanium and germanium and germanium. So you see here, each germanium is having what? 4 valency. This germanium also having 4. This germanium also having 4. Every germanium atom is having what? 4 valency. Means it can form 4 bonds. Why? Because this germanium belongs to fourth group. It will possess 4 valence electrons, so that it can form only 4 bonds. So when this germanium atom is replaced by 15th group elements, pentavalent means 15th group element. Which element is having 5 valency? That element is called what? Pentavalent. Let's say I am taking, in place of one germanium, I am going to take another element which belongs to 15th group. That is arsenic I am taking, let's say arsenic. So arsenic will have 5 valence electrons. That 5 valence electron will be utilized in the bond formation. Let me check if arsenic is having 5 valence electrons, but in that how many electrons it can use for the bond formation. Here arsenic can form one bond with this germanium, so because of that one electron will utilize by this arsenic. Total how many left? 4 left. Then one more electron will be utilized here to participate bond with germanium. How many electrons will left? 3. Now one more electron will utilize to form bond with this germanium. How many electrons left? 2 electrons left. One more electron will utilize to form covalent bond with this germanium. Total valence electrons of arsenic is 5. In that 4 electrons it is utilized to form covalent bond with adjacent germanium atoms. Then how many electrons left? Only 1 electron is left. So because of that electron, the conductivity of this germanium semiconductor will increase. Electron is having negative charge. So that's why this semiconductor is called what? N type of semiconductor. Because of negative charge, conductivity will increase. So that this semiconductor is called what? N type of semiconductor. So in this, N type of semiconductor is present in option B. So that's why our answer is option B. I hope this question concept is clear to you. Next we will go for third question. So in this third question they are asking packing efficiency by the arrangement. Packing efficiency by arrangement of the atoms in two-dimensional hexagonal close packing is. First let me explain what is two-dimensional hexagonal close packing. So in two-dimensional close packing is different. So two-dimensional hexagonal close packing will form like this. So one atom, 2 atoms, 3 atoms, 4 atoms are joined like this. So this is first layer. So if you observe second layer will come in between these 2 atoms. So because of this only the hexagonal close packing will come. Again third layer will come like this. So the third layer will come like this. If you observe, this first layer and third layer is matching. So this is A layer and this middle one is B layer and this one is A layer. If you observe carefully in this, how the hexagon will form. So here if you take this, select this element is contact with how many elements? So 1, 2, 3, 4, 5 and 6. So when six atoms are joining together, then hexagon will form. This is hexagon. One hexagon will form. So this is called what? Two-dimensional hexagonal close packing. So they are asking packing efficiency of hexagonal close packing. So first, what is the formula of close packing? That we will discuss first. What is the formula of close packing or packing efficiency? Packing efficiency formula will come like this. So volume occupied by the total atoms. Volume occupied by the total atoms. Volume occupied by the total atoms. Volume occupied by the total atoms upon volume of the cube or volume of the hexagon. In case of hexagon, volume of the hexagon we have to consider. Volume of the hexagon. So how can we calculate volume of the hexagon? So very simple. So hexagon arrangement will be like this. Hexagon arrangement. So here one atom will be there. Here one atom will be there. Here one atom. Here one atom. Here one atom. Here one atom will be there. So these all atoms are close. Here maintain distance, but these two atoms will touch each other. So if you observe this hexagon, we can divide like this. Hexagon is formed like this. Okay. So we can divide this hexagon like this. Here one we can take like this, and another one we can take like this, and another one we can take like this. So if you observe each and every structure which is formed here, it seems to be a triangle. Then how many triangles are there? You check here. 1, 2, 3, 4, 5 and 6. 6 equilateral triangles are there. The formula, the area of the 6 equilateral triangle, each equilateral triangle is root 3 by 4 into a square will come. Root 3 by 4 into a square. Root 3 by a square. Here a means what? Edge length. This one. Root 3 by 4 into this one. Edge length will come. Root 3 by 4 into a square. Here a means what? Edge length will come. This one. So total how many triangles are there? 6 triangles are there. So 6 into root 3 by 4 a square will come. 6 into root 3 by 4 a square. This is the volume of the hexagon. Then what is Z effective in case of hexagon? So each atom will contribute 1/3 part of this hexagon. Total how many atoms are there in hexagon? 6 atoms are there. 6 into 1/3. So in between these 6 atoms, one more atom will be there. That is 100% belongs to this hexagon. So that is 1. So 3 1 ja, 3 2 ja. So that 2 plus 1 which is equal to what? 3. So now what is packing efficiency? Volume occupied by the total atoms upon volume of the hexagon. Volume occupied by the total atoms. Total atoms are how many? 3. 3 into pi r square. It is two-dimensional, so that's why it is not volume. We can take it as the area. Next is 6 into root 3 by 4 into root 3 by 4 into what? A square. So in place of a we can take 2a. We can take 2r. Why? Because this is r and this is r. That is 3 into pi r square upon 6 into root 3 by 4 into what? 2r whole square. If you simplify this, you will get 90.4%. You will get 90.4%. Into 100 we have to do here. Into 100. For packing efficiency we have to calculate for 100. So 90.4. Actually in this question 90.4 option is not there. But 90.4 option is not there. So here due to printing mistake 90.4 not there. I think this supposed to come as 90.4. So this is answer. Option A is answer. 60.43 will not come. Okay. Next. Fourth question. The radius of the calcium ion 94 picometer and of the oxide ion is 146 picometer. The possible crystal structure of the calcium oxide will be. So to understand this type of questions, we have to take the ratio of cation and anion. Here cation is calcium 94 upon 146. 94 upon 146. If you divide 94 and 146, you will get 0.643. You will get 0.643. 0.643 will get 0.643 is responsible for what? Octahedral geometry. If the radius ratio is in between 4142 to 732, it will come octahedral geometry. So that answer is what? Octahedral here. Next question. The interionic distance for cesium chloride crystal will be. So cesium chloride crystal is body center